My name's Derek Hullinger. I have a PhD in physics, and I'm going to explain how to use a z-table in probabilities. So z-tables are useful for something called a Gaussian distribution. And a Gaussian distribution is just it's a curve or a function that looks something like this. It goes up and then back down, and then it goes really low on both ends, something like that. And every Gaussian distribution has two ways that you can describe it. One is where its middle is located. So where that center is, and we usually use a symbol called mu to explain that. And then the second is how wide it is. So for example, from the middle out to about the edge of it right there, that's called the standard deviation, and they use the Greek symbol sigma to represent that. And so, for example, let's say that we have a Gaussian distribution, and the mean is, say, 10, and the standard deviation is maybe 4. So something like that. So let's say that there's a point on this curve at 16. So let's see. Right here, we would be at 14. And so 16 would be about right there. So 16 is one standard deviation plus a half a standard deviation away from the middle. So that's what we mean by the z-score of a number. It's how far a point is away from the middle of the standard, or the middle of the Gaussian distribution. So for this point right here, z is 1.5. If you have another point, say like 21, that's a lot further away from the mean, and it turns out that z is 2.75. So it's 2.75 standard deviations away from the mean. So kind of a good way to do this in general is, if you know what the point is that you're interested in, all you have to do is subtract off the mean and then divide by the standard deviation, and that gives you your z-score. So what's the point of needing a z-score? Well, it turns out that if you imagine that the total area under this curve is 1, or 100%, you can look up in a table and see how much of the curve is to the left of a particular z-value. So for example, suppose for a certain point you had z of 1. You could look up in a z-table, and it would tell you a number of 0.8413. That means that 84.13% of the curve is to the left of that point that represents z equals 1.0. Or you could look at the same column of z equals, or the same row of z equals 1.00, and then go over to the 0.03 column. And when you look at the 0.8485, so that means that a little bit more of the curve is to the left of that point, in this case 84.85%. So that's how you use a z-table.